Hey, welcome back. We're like just about to start. You perfect timing, Callie. Yeah. Folder. Okay, I think we're good to go. Okay, yep, we're good here. I'll take my hat off so that way you can see my face. First off, before we get started, any questions about 3.2? And if you want to put something in the chat, that's fine. If you want to like give me a thumbs up or a wave to let me know, yeah, I do, and I can call on you, because so you don't want to like talk over anybody. I understand completely as well. Get this lined up kind of so I know where the edge of my screen is. Right there. Okay, any questions about 3.2 before I go on to today? You know, we've all worked a job. I mean, maybe some of you haven't, but if you've worked a job, there's like mundane things that you do over and over. And then there's like some things you kind of look forward to and you're like, I don't know why I enjoy this part of this job, right? But for some reason, I enjoy lecturing this section. I don't know why. I look forward to it. I have no idea why. But some of them I just not dread lecturing, that's not the right word. It's just more, it's just get it over with, you know. But this one, for some reason, I get a little hyped for, and I honestly don't know why. I don't know why this one gets me excited, but it does. And I teach it a little, I'll tell you, not that I teach it, I go over it a little different than the book. I feel like your book gives you a little too much. You don't need all that information. I kind of trim it down a little into what's going to help us, especially when we get to 3.4. Okay. Okay, good. So if you guys don't have questions about 3.2, I'm going to go on. And before I really start today's lecture, I'm going to talk a little bit about what we talked about at the very end of 3.2, which was solving for those zeros. And it was like, let's look at one in factored form. If I give you a function, a polynomial function in factored form, let's say 4x minus 7. Let's say I gave you one like this. So we've got x minus 1, we've got 2x plus 3, and we've got 4x minus 7. And I mean, what we learned in the last section was we know there's going to be 3 zeros. The degree is 3. The leading coefficient would be 8, because you do 4x times 2x times x and x cubed. So I know the end behavior is going to be opposite, all that fun stuff. Okay, we'll get there. We'll talk about that again at the end of this lecture a little bit. But if I asked you to find the zeros from this, so if I just said find zeros, we know there's going to be 3 of them because there's 3 factors, right? And so from this first one, from x minus 1, if that's the factor, we just move the 1 over, right? This isn't crazy. I'm not trying to trick you. Okay. X equals 1. So I need you to, for what we're about to do to really work, I need you to get that. Look, if we have x minus 1 as the factor, x equal 1 is the 0, right? Okay, so then if we had 2x plus 3 equals 0. If we solve for this one, look, I'm going to do this in one step. I'm going to make this a little efficient. We're going to subtract the 3 and then divide the 2, right? So you wind up with negative 3 halves. So if 2x plus 3 is the factor, negative 3 halves is the solution. And it comes from subtracting the 3, dividing the 2, okay? Subtracting the 3 and then dividing the 2. So really, if we have a denominator here, it comes from the coefficient on the x value, okay? It comes from the coefficient on the x value. So it'll happen on this last one as well. Yeah. So if we've got 4x minus 7 equals 0, you add the 7 and then divide the 4, right? So you wind up with 7/4. Add the 7, divide the 4. Okay, I wanted to go over that first because this is gonna come into play where the way we're gonna learn how to dividing polynomials is the subject of this section. But the way we're gonna learn to divide polynomials is actually based on the zeros. It's based on really finding the zeros, okay? It's an interesting kind of way to do it. And again, okay, so now let's kind of start into the lecture today. Today we're going to divide polynomials, and before we divide polynomials, let's go back to 4th or 5th grade and remember how to just divide numbers, okay? Because it's the same terminology we're going to use. Same terminology I'm going to use to divide, but instead of just numbers, it's going to be polynomials. Okay, so let's look at this. Let's say I wanted to divide, let's do something that divides evenly. Let's say we've got 27, and I want to divide it by 9. Okay, 27. And actually, you know what? Let's do, yeah, this will be fun. 27 divided by 9. Okay, there were a few different ways to write this, actually. Now, when you first learned division, it was 27 and then that division sign, right? Now, notice that division sign is just a notation of a fraction. That's where it actually comes from. You see, it looks like a fraction with a dot on top and bottom. It's because really division is just a fraction. Okay, that's where that notation came from. And with this 27 and this 9, you probably learned it like this. You might have learned it a little differently, but we wrote it like that, right? And then this is called the dividend. We're going to use that same terminology. And this is called the divisor. Okay? The dividend and the divisor. And we say, how many times does 9 go into 27? And you all say, 3. And we put the 3 up here. And when we put it up here, we multiplied it and we got 27. You subtracted it, right? Now, this number here is called your quotient. Quotient. I spelled right. Okay? It's called a quotient because it's what happens. It's what you get when you divide the divisor into the dividend. And the number down here was actually your remainder. Okay? Cool stuff. Now, up here, this just means that this equals 3, right? We could write it like that. Now, what's cool, though, is when we do this today, this is all the same terminology. It's just instead of numbers, it's going to be polynomials. We're going to be dividing polynomials into polynomials. Okay. Now, the big thing here that was important, and really what's going to be more important for us today when we're dividing into polynomials, and then when we get to section 3.5 or 4, is that this is 0. Okay, look, I'm going to write this here. This is a good thing. Okay? The remainder being 0 is a good thing. It's a really good thing. Because what it tells us not only is 9 evenly a factor of 27, right? 9 times 3. It also tells us that 9 times 3 equals 27. In a way, we factored this. So here, let me show you what I'm talking about. If we know 27 divided by 9 equals 3, it also means that we can move the 9 over, and we know that 27 equals 9 times 3. Now, we all know this, right? We know that 9 times 3 is 27. It's not a big deal. But we're about to get to polynomials, and it's going to be a lot harder to really see per se, okay? That's all based around that remainder being 0. If that remainder is not 0, this is not true at all, okay? We'll do one here in a second on what this looks like if the remainder is not 0, okay? Questions? So we travel back into 3rd grade or 4th grade. Right? So let's do one that isn't divisible, or that isn't has a remainder. We'll say it like that. And this will show you how the book likes this answered. Let's do one that's like 417, and we're going to divide this one by 5. We know that's not divisible by 5. Okay, right? We know this isn't divisible by 5. It isn't in a 0 or 5. So we do the same thing we did before. 5 goes into 417. Well, 5 doesn't go into 4, right? So it goes into 410, and it goes in, how many times is that? 8? 40. We subtract, we get a 1, bring down the 7, we get a 3. We've got a 2. Now, if we wanted decimal places, we could keep going, right? We put a 0.0, bring it down, and just keep going that way, but we don't want to do that. What we found is that this has a remainder of 2, which is not good. If you want to make a frowny face, you can, okay? That's not good for us. And really what it does, for us, it shows or kind of proves that 5 is not divisible, 5 isn't divisible, 417 isn't divisible by 5, I should say it correctly. Now, these are all still the same thing. This is still your quotient. This is still your dividend. This is still your divisor, okay? But we had to write this differently because it's not equal to a nice integer, okay? Now, there were a few different ways to write it. The very first way you learned to write it was like using a lowercase r. Do you remember that? And it was just 83 R2. Anybody remember that at all? Ooh, it's been a while, right? And what this really meant, though, was that 417 divided by 5 is really 83. And what you do is you actually take the remainder and divide it by the divisor. 83 and 2/5. So 83 and 2/5. Now, this is called a mixed number, right? Because it's got an integer and a fraction in it. The way your book wants you to write this, once we get to the polynomials, is you take the quotient and then you add, and you're going to put the remainder divided by the divisor. These mean the same exact thing, okay? These mean the same exact thing. Okay? Questions, comments. I mean, think about this. If we measured something, somebody told us like, hey, you know, this one building is 400 and let's say 214 inches tall, right? It's like, oh, 214 inches tall. I have no idea what the, oh gosh. The worst is whenever someone, hold on, I'm gonna change this up. Someone tells me their height in inches. I don't know what the hell that means, right? So if someone says, you know, I'm 73 inches tall, or let's say 74 inches tall. I'm like, I have no idea what that means, but I can divide it by inches, right? 12 inches, and I can get this into feet, okay? And it kind of makes more sense. You'll see. So I know this isn't divisible by 12. If we think of this as how many times does 12 go into 74? Okay. It would go in 6 times, right? 6, because that's 72, yeah. So 6, this is 72, subtract, and I wind up with 2. So this is actually, and it makes sense to think of it as a mixed number. And actually how we say people's height is really a mixed number. We just use a different notation for it. So this would be 6 foot and then 2/12 of a foot, okay? 6'2". So 74 inches is 6'2". Now we would write it as 6 plus 2/12. And I know what you're thinking, but it should be 1/6. You have to simplify that fraction. And you should. Mathematically, you should simplify 2/12, but it makes more sense for this example because it's a real world example and we're talking about inches and feet to leave that as 12, right? It makes a lot more sense. So for this one, I'm going to leave it as 2/12. Okay, that's just a real world example that you've probably encountered before. Okay, maybe not. Not a big deal. Okay, let's get to the actual lecture. Oh my gosh, 15 minutes in, I'm talking about height. So now let's get to actually the long division of polynomials. So your book goes over 2 ways to do division of polynomials, long division and synthetic. I am not going over long division because it is tedious and you do not need it to really do the concepts of college algebra or of trig or calculus if you want to go on, okay? You're more than welcome to look over it. And if you want to come up to my office, I'll tell you all about long division of polynomials and we can talk, you have a personal lecture from me on it. But what we're going to talk about is synthetic division, okay? Synthetic division is a very efficient way to divide polynomials, extremely efficient way to divide polynomials. It is definitely not long division. It would almost be called like short division, I guess, really. But it was appropriately given the name synthetic division. Now, there's a few rules with synthetic division. Oh, Lord, it's hard for me to talk. The first one is when we set this up, the polynomials have to be in descending order. So the polynomials must be not just in descending order, but in descending order. Oh, I'm not going to spell that right. That's not right. Descending order with missing terms. And we're going to go over what that means in a minute. Polynomials must be in descending order with missing terms. And the other big one is that your divisor must be in the form x. Now it can be plus or minus, it doesn't matter. So I'm going to just say x plus c, okay? It can be minus c, it's not a big deal. But it has to be a first degree polynomial, x, by itself, and then plus or minus a constant, okay? Those are the two rules to do this. Now, to set it up, I should say. Those are the two rules to set it up. So what do I mean? Let me steal one where maybe I have to. Yeah, okay. Give me just one second. Let me find a good example in the book that I want to use here. Let's see one that works first. Here we go. Okay, so let's say I've got some polynomial, 2x cubed. Actually, I'm going to rewrite this one. Let's say minus 3x squared plus 2x cubed minus 11x plus 6. So I've got this polynomial minus 3x cubed plus, you guys see that minus? Yeah. Minus 3x cubed plus, minus 3x squared plus 2x cubed minus 11x plus 6. Now we're going to divide this by x minus 3. We're going to divide this by x minus 3. Okay, so we got minus 3x squared plus 2x cubed minus 11x plus 6, and we're going to divide it by x minus 3. Now, look, the first rule of synthetic division is that polynomials must be in descending order with missing terms. If we look over here, this is not descending order, okay? For descending order to occur, you have to have the degrees of each term in order from top to bottom. So 3, 2, 1, and then really 0. So the first thing I'm going to do is rewrite this in descending order. So 2x cubed minus 3x squared minus 11x plus 6. Okay, this is descending order. Ooh, I won't write off the board, but that's descending order. Now we're going to divide it by. Now notice our divisor is set up correctly. Now I know it's not plus the number, it's minus, that's fine, but it is just x minus 3. Okay, it's x by itself, and then it's plus or minus a constant. That's what we have to have. Okay, that's what we have to have. Okay. So if you want to watch me this first time, that's fine. I'll go slow enough where you can follow along. But if you've never done synthetic division, it looks like I'm about to take a magic wand out, wave it around, and poof, I have the answer. Okay? So if you want to watch, that's fine. And if you want to write it down right after, that's okay as well. But just to kind of soak it in, sometimes students just need to see it first. Okay? So here's how we set it up. To set up synthetic, we make like this big L. Okay, let's make a big L. And look, we're going to go to the divisor. And this is why I went over the very beginning example in class. And remember, if x minus 3 was a factor, what would the 0 be? I'm asking you guys. You can yell or you can type in the chat. If x minus 3 was a factor of a polynomial, and we wanted to solve for the zeros, what would the 0 be from this factor? Say it again, Kelly.
3.
3. It'd be 3, right? It would be 3. So yeah, perfect. Hold on. Jeanette, perfect. 3. Okay. And so that's actually what we're testing in synthetic division. Synthetic division was really used to test the 0. Okay. So let's go back to our synthetic division. If it's x minus 3, you're always going to change the sign here. So minus 3, it's going to be a positive 3. And I'm going to write it right there. Okay? And really what that is, don't tell the book, it's a potential 0. Okay? We'll get there in a minute. It's just a potential 0. And then I'm going to write the coefficients descendingly. Okay? So what I mean by that is I'm going to look at my quotient and I'm going to write all of the coefficients descending down. So 2, -3, -11, and 6. Okay? 2, -3, -11, and 6. So if we set this up properly, it takes 2 seconds to divide it. Okay? So I'll just set it up properly. So here's the flow of synthetic division. The first thing you do is you bring down the very first coefficient under the line. If a number goes under this line, you divide it by this potential 0. 2 times 3, 6. And I put it right here. Okay? And then you add vertically. -3 plus 6, that's just a positive 3. Okay? Then again, if it's below this line, you multiply it by the potential 0. 3 times 3, that's 9. And I put it here. Okay? And then I add vertically again, and I get a -2. And then once it's below the line, I multiply it by the potential 0, -6. And in the end, I get a 0. Okay. We've done it. We've already divided. It's just hidden in here in a way. Okay? So what we found are actually the remainder and the coefficients of our quotient. Okay? And what happens is it's easier to kind of work right to left here. This number is always going to be your remainder. That's our, for us, we were lucky. It's 0, right? That was a good thing. It meant that this was divisible. This x minus 3 is a factor of this third degree polynomial. Okay? And it's because that remainder told us so. And then your quotient's coefficients are right here. Okay? So I'm going to write this out. What we found, I'm going to write it again. 2x cubed minus 3x squared minus 11x plus 6 divided by x minus 3 is equal to, the suspense, I know, is 3. Look, this is our constant. This will always be our constant. So it's going to be remainder, constant. This is going to be the coefficient of x. This is going to be the coefficient of x squared. And if it kept going, we'd have the coefficient of x cubed. The coefficient of x is a 4. So it looks like this. 2x cubed. Oh, no, gosh, I lied. 2x squared plus 3x minus 2. I'm going to do one after this with the remainder to show you how to deal with it. Okay? But here, I'll kind of show you where these are coming from. That's where they're coming from. Okay? The 2 is there, the 3 here, and the -2 there. Okay? Another thing that is interesting, that it's something to keep in mind when you're doing this, is remember when you divide exponents, you subtracted the exponent? Like if it was x cubed over x, and you were simplifying it, this would be x squared because it's 3 minus 1. Well, it turns out to be true with the degrees of polynomials as well. Look, the degree of this top polynomial is 3. The degree of the bottom polynomial that we're dividing off is 1. This will always create, when you divide, a polynomial with a squared because you're subtracting 3 and 1. So it's going to give you a second degree polynomial. You don't have to know that, but it's kind of interesting. And really, at first, we're just going to be learning about, we got to get this reflexive division, okay? The reflexive division we've got to get down. Okay. Any questions about this one other than, I need to see about 4 or 5 more of those before I really get it, which I understand. I mean, you really have to, this is one of those, like, math is not a spectator sport, right? You've got to be in there and do this to really get it to work. Okay, let's do one, and I'm going to tell you this one's going to have a remainder. This one will have a remainder, and let me steal it from the book, so I'll make sure it has a remainder. Okay, yeah. So this is 5x cubed plus 6x plus 8. Now I want to divide this by x plus 2. Okay, 5x cubed plus 6x plus 8. And I'm going to divide this by x plus 2. Okay, so this one, now we're in descending order, right? Cubed, x, and a constant, but we have a missing term. We have a missing term here. We don't have a squared term. Do you guys see that? We got a cube term, we got an x term, we got a constant. We don't have a squared term. So when you set this up for synthetic division, you have to have the missing term. So what that means is we have to think of this polynomial as 5x cubed plus 0x plus 6x plus 8. Okay? We have to think of this polynomial as 5x cubed plus 0x plus 6x plus 8, and then we're going to divide it by x plus 2. Okay? Now, I want you to do this synthetically now. So I'm going to set it up. I want you to try it. Now, look, x plus 2. Remember, x plus 2 is the factor. Minus 2 would be the 0. So it's going to be a negative 2. And then our coefficients are going to be 5. This is why we have to put in that 0. If we don't put that 0, that missing term in, it messes it all up. It doesn't, synthetic doesn't work then. So 5, 0, 6, and 8. And I'm going to tell you, you're going to wind up with the remainder. Try that. I'm going to go get some water, and I'll be right back. Okay, let's see. So we got. So bring the 5 down. We got a 5. -10. Add that, we get a -10. -20. Add that, we get what? A -14. Multiply that, we get 28. What's that? 28 plus 8?
36.
36. That's not what the book got.
Yeah, I got something.
I got something. Yeah, the book did too. So hold on. I got to go back to where I stole this.
I got a positive 6 plus 20 because the negative.
Oh, you're right. Yep. -2 times -10 is positive. So therefore, this is 26, right? Which then becomes -52, which becomes -44. Yeah, right. That's what the book got. Okay, but now remember, this is a remainder, right? So I've got to be careful. This one won't have as nice of an answer. Like over here, we didn't have to worry about the remainder and how to deal with it. And we're going to deal with the remainder the same way we dealt with in the division questions from earlier. We're going to first write our quotient. So this is going to be equal to this quotient, or I'm sorry, dividend divided by divisor. It's going to be equal to, now look, this is our constant, this is our x, and this is our x squared. So 5x squared minus 10x plus 26. But then, remember, we add the remainder over the divisor. So plus, and I'm going to do remainder -44 over our divisor. Now, our divisor was x plus 2. So that's how you would write this as a division. Now, I'll tell you, for our purposes in this, actually at the end of this section and 3.4, we're going to wind up just kind of tossing this one out if this happens. We need remainders of 0, okay? We need remainders of 0. Okay. Questions? I'm going to have you do another one. Okay, this other one, let's see if we wind up with the remainder here. I'm going to steal this one as well. Let's say, yeah, let's say we've got x squared plus 10x. I'll set this up nice. Okay, this one will be ready to go. X squared plus 10x plus 21. And I want to divide this by x plus 3. So I want you to try this one completely. It's in descending order. There's no missing term. So try this one. All right, let's see what happens. Now, if x plus 3 is the factor, minus 3 would be the, hopefully, potential 0. We'll get to that here in a minute. And then we wind up with 1, 10, and 21, right? So bring the 1 down, -3. Add, we get a 7. Multiply, we get a negative 21. Oh, yeah. There. So we only have 1 and 7 here, which is fine. Because look, we're dividing a second degree by a first degree. So that's going to leave us with a first degree polynomial. So what that means is, or what we found actually, is that x squared plus 10x plus 21 divided by x plus 3 equals, now look, this is our constant and that's our x. So I'm going to write the 1 here, you don't have to, but it's 1x plus 7. That's where they're coming from. Okay, 1x plus 7. That's because we had a 0 remainder. We didn't have to write like plus, you know, yeah, I guess you could write plus 0 over the divisor, but 0 divided by anything is 0. Okay. Questions? Comments in Zoom world?
Can we do another one? Because I was completely wrong.
183. Where did you get 183 from?
I put the 1 down and then multiplied -3 times 1 instead of going to the 10.
Oh, no. So you did -3 times 1, and you got the -3, right? But then 10 plus the -3 is a positive 7.
Yeah, I multiplied that -3 by the 1 at the top.
Oh, I got you. I got you now. Yeah, it's this one right here, right? Yeah, hold on, Alex. We'll definitely do another one. Sit tight. But I want to go over what this means, okay? I want to go over what this means. What we found are actually the factors of our quotient, okay? So another way to write this is x squared plus 10x plus 21 equals x plus 7 times x plus 3. This is where this is leading us, okay? Remember how if you think back whenever it was like 27 divided by 9 is equal to 3. Oh, that really means it's 27 equals 9 times 3. It's the same thing. This is where we're headed, okay? This is why we're doing this, because we're going to try to break down these quotients, these functions into all their factors, okay? And the way we do this is by synthetically dividing out zeros. And yeah, Alex will definitely do that. Definitely. Okay. Let me steal one from the homework then. Okay, let's do a look through here. On page 374, let's do, I'm going to choose an even one that way because I'll give you the odds for homework. Let's do number 20 on page 374. So number 20. And number 20 states 5x squared minus, not 112, R&B group from the late 90s, early 2000s, I'm not sure. A long time ago. Minus 12, minus 8. So 5x squared minus 12x minus 8 divided by, is it x minus 3?
Plus 3.
Plus 3, yeah. Okay. So try this one now. Try this. So I gave you that. I mean, if you're looking at the homework, it looks just like this. And it says, divide using synthetic division. Give me just a minute. almost have the same divisor. Oh, I see, Alex, what you're saying now. Okay, keep working if you're working. I'm gonna try this one. If I set it, and again, we have nice descending order. There's no curveballs here, right? But we got a -3, a 5, a -12, and a -8. Okay, so I've got to bring down the 5 first. And then I multiply it by the divide, or by the really potential 0, -15. Add that, I'm in a big number, right? -27. So -27 times -3 is a positive 81. Yeah, that's a big number, right? So then we wind up with like 70. Oh yeah, positive 73. Right? That's our remainder. It doesn't help us out. And you're probably thinking, God, 73, I probably got this one wrong.
That's
Right.
what I was thinking. I was like, either I'm spot on or I'm way
Off. Yeah. There's some, I'll tell you in the homework, there's some that have remainders in the thousands. So don't get freaked out. Yeah. Don't get freaked out if you're doing this and you wind up with a remainder that's like 1,300. And I think they do that just to kind of mess with your head a little. But let's see how to write this. Okay. So this is equal to, it's not going to help us with factoring, right? But it's equal to, now that's our remainder, our constant, and our x. So 5x minus 27 plus, and now we do remainder over divisor. Okay. Did you get that one, Alex? I'm going to pick on you now a little bit.
Sure did. Very proud of myself.
Yes, I'm proud of you too. You should be proud of yourself, Alex. You should be proud of yourself. This, I'll tell you, typically what happens with this, students watch it a few times, and not just you, Alex, watch it a few times. They get the pattern down, and then they get overly confident. And then it's like, if it throws you a curveball, you might miss it because you're overly confident. So just be careful that you set it up all correctly, okay? And then just, I mean, you can use a calculator to make sure the little, you don't do 5 times 6 equals 11, that kind of stuff, okay? It happens. And it's the worst way to miss a question. Okay, let's do another. Let's do another one, and then, oh my God, let's do one of these. These look kind of crazy there towards the end of that little section. Oh my Lord. Okay. I don't know what the answers are to these because it doesn't say in my book, but they do look kind of crazy. Let's look at 26. 26 says, same page, 374, number 26. X squared minus 6x minus 6x cubed plus x to the 4th divided by 6 plus x. Okay, we gotta clean this one up a lot before we can divide. Okay, let's see here. First off, this is not in descending order, and it has a missing term. Like, let's start, if you're just not sure about the missing term thing, pick out the degree term. If I look at all 4 of these, the degree term's right there, right? I'm gonna start with that degree term. That's what you have to start with. And then you just work down. Okay, my 3rd degree, oh, that's right here. Minus 6x cubed. 2nd degree, right there. My x, my 1st degree. But look, notice there's no constant here, and you have to have a constant. So I know this looks goofy, but you have to have a +0 because that +0 is a column in your synthetic division, okay? That constant, all of these we've done, look, that's a column there. It's got to be there, okay? That constant from up here, got to be there. And then we're actually dividing by, I mean, this isn't that big of a deal, but it's really x plus 6, not 6 plus 6.
Wait, why did you do that x to the 4th first?
Because it's if you look at all 4 of these, it's the highest degree term.
Okay, so that goes first no matter what.
Always, and then it descends down. I erased that one part. Remember?
Oh, okay, I see now.
Yeah, it descends down. 4, 3, 2, 1. It really tells you where to start, right?
So you don't add those two together, like the x to the fourth and the x to the second.
We can't do that
Okay.
because they're not like terms.
Okay.
Remember, to have like terms, you have to have the same exponent to have like terms. So these are all just separate. And now, hey, look, if this was a 4 here, we would totally add that together. Okay, but we don't. I mean, it's just a different term. It's not a like term. Okay. Whew. Man. So now let's divide this out. Actually, you guys try this one. So -6, right? And we'd have a 1, a -6, a 1, -6, and 0. I'm going to start, keep working through order. I'm going to start this one. This would be 1, -6, add, we get -12. Oh no. -12 times 6 is, we did that one earlier, right? 72 positive. Don't want to get that wrong again. Add that, we get a 73. Oh no, I need help. What's 73 times -6?
-438.
Oh my Lord. Add that together, I get -440. Thank you. I have one more to go, right? I gotta multiply that by -6. I'm gonna move my 0 a little. Help me out.
Positive 2,664.
Okay, did you get that? Caleb, great. Yeah, you add this together and that becomes your remainder, which is crazy. I knew this one had a crazy remainder. That's why I chose it. Okay. That's your remainder. Woo, holy cow. So what we found though is this, or you can go back to the original, is equal to, now let's think about this. If that's our remainder, here's our constant, here's our x, here's our x squared, and this one's an x cubed, which makes sense because we had a 4th degree divided by a 1st degree. So that's going to leave you with an x cubed, 1x cubed if you want to write it. The 1 minus 12x squared plus 73x minus 444 plus, now we've got remainder over divisor. Pretty cool. Okay. Pretty cool. I'm going to use this one actually for my next math trick. No. Questions, guys. Now look, we're going to do some more synthetic, but I'm going to go on to the next topic and then we'll come back to how we're really going to use synthetic division. Okay, so the next topic is the remainder theorem. It's on page something or another. It's on page 371. And it says, look, if, this is the remainder theorem, if some function, some polynomial function, is divided by x minus c, they use x minus c so you know to change the sign, then, nice if-then statement, the remainder is f of c, okay? If f of x is divided by some function, or by some binomial x minus c, the remainder is f of c. Now, I'm going to use our last example here. So get your calculator ready. Let's say that our dividend up here was our function. And I'll use, it doesn't matter, we'll use the first one. X squared minus 6x minus 6x cubed and plus x to the fourth. Let's say that was our function. And it's a polynomial function, 4-degree polynomial function. It meets the requirements to be a polynomial. If we take this, if f of x is divided by, and let's divide it by this, x plus 6. What's neat here is, remember, if x plus 6, really you change the 6, you change the sign of the 6 here. So negative 6. If you plug in that potential 0 that we put up here, it's going to give you the remainder. It'll give you the remainder. So I want you to get in your calculator real fast and pop this in. So do parentheses negative 6 squared. I'll write it down here. Let me write it kind of over a little bit. F of negative 6. So do an open, if you look at that calculator, give it, okay, here, just tweak it. Oh, no, I've got mine. If you're really not comfortable using this thing, I'm going to go by it step by step real fast. So the parentheses button is right above the 8. So open that set of parentheses. And then to use the negative, because it's a negative 6 that we're plugging in, the negative button is down there by the decimal, okay? You've got to put that negative in. The other sign over by the number 6 is a minus sign. We don't use that. So we've got negative 6. We're going to square it. The squared button is right by the comma, kind of catty corner from the 7. So it's negative 6 squared. Make sure to close that parentheses and then square it. And then what's next? Oh, minus. Use the minus sign over by the number 6 above the addition sign. 6. Another set of parentheses, negative 6. Okay. And then another minus sign. 6. Open a set of parentheses. Negative 6 again. Now look, to get that cubed, we're going to use the caret button. It's right above the division, all the way to the right on the calculator to under the clear sign. And it looks like a little caret. If you've got an older calculator, it'll actually put the caret there. If you have a newer calculator, it automatically puts the number in the exponent, right? And then, so if it automatically puts the number in the exponent, just put in 3. So it'll do a little box and put in 3. And to get back down to the regular, you got to hit to the right and then do plus negative 6. This has to be in parentheses. And then do the same thing again, caret and then 4.
A lot of 6s.
Say again?
It's a lot of 6s.
It's a lot of 6s. Yeah, you're right. Oh, yeah, because even the coefficients are 6s. Okay, when you do that, Kylie, when you pop that in there, hit enter. What do you get back?
2,664.
Right? And if you didn't, we probably made a goofy mistake. I'll do an easier function on this next one, okay? But we probably made a goofy mistake on how to write this in. This is a horrible first example if you've never used that calculator before. So don't get frustrated if you didn't get 266. Give me a second shot here, okay? This is just a really hard example for a calculator. But notice we divided by x minus c. So we put in c, we changed the sign to the c, right? Which is really what we did over here with synthetic division. we plug that number in to the function, and it will give us back our remainder, which is awesome. What this tells me, before I do any synthetic division, is that I know this x plus 6 is not divisible by this function, right? That's what the remainder theorem told us. That x plus 6 is not divisible by our function. Pretty neat, okay? Let's do one that'll just be a little easier to put in the calculator. Well, they only did like harder ones. Come on now. I'll make one up. Let's do, let's do one. So let's say I gave you a function was f of x equals, let's do x squared minus 16. So f of x equals x squared minus 16. And I want you to divide, or really, how about this? No, divide, wait. How would you write this? Hold on. Let me see how they're writing in the book. Use synthetic division and the remainder theorem to find the indicated function value. Oh, okay. I see what you're doing here. So they want you to find let's do find f of 4, and we're going to do it two ways. One, by plugging it in, and then by synthetic division. And this will just kind of show you how these intertwine. By plugging it in, and then by using synthetic division. So I'm going to plug f of 4 into this function, so I get f of 4 equals. Now again, I'm going to put this in just like I would in your calculator. This one will be easier because it's not as many terms. So parentheses 4, square it, right? And then minus 16. And what do you get back?
0.
You get back 0. And again, this is a smiley face 0. Because remember, this is just your remainder, okay? We know now we're going to do synthetic division on these to show another example. We're going to do synthetic division on this, and we're going to get a remainder of 0. So now if we found 0, or the way to find this with synthetic division, I'm kind of stumbling over my words. The way you find this with synthetic division is now we're going to use that number on the outside, right? We're going to use the exact number because really it came from x minus 4. And now be careful. If we're going to write this in synthetic division, we have to write it with the missing term. X squared plus 0x, right? There's not an x value. Minus 16. We have to remember the missing term. So it would be 1, 0, negative 16. So divide that out. I'll give this another good example of synthetic division. Now look, we know, as you're working, we know this should be 0. We found the remainder already, right? That should be 0. If we don't get 0 here, we did something wrong. We either didn't set it up properly, or we just we made a goofy math error. Let's see. And then 1 multiplied by 4. Add it, we get 4. Oh yeah. Checks out, right? It checks out. That's what it's asking you to do with this synthetic division. Now, I think I think the remainder theorem is kind of just it's kind of crazy. Remainder theorem is just kind of a neat thing. I guess that's the best way. It's like kind of a neat trick, you know. We won't use it that often. I'll tell you that. It won't be used that often, but it is kind of neat. It's there. It's good to know, but it just won't get used that often. And really what I want to spend the last 12 minutes or so in class on, 15 minutes, I guess, or 12, I think my clock's still on that laptop. I want to talk about really what this is leading us to, which is the last part of the regular homework, really, is what I'm talking about. And if we looked on page 374, and I want you to look at number 42. Number 42. Number 42 states, use synthetic division to divide f of x equals x cubed minus 2x squared minus x plus 2 by x plus 1. Okay, so that's really kind of part A. A, use synthetic division. And then it says use the results to find all the zeros. So I'm going to slowly do this one. So A, I'm going to divide synthetically. We know how to do that from today's lecture. I mean, if you're still iffy on it, just another good example. And part B, use the results to find all zeros. Okay, we'll get to the part B. That's the new part. Let's do the part we know already, part A. Okay, we don't have any missing terms. It's in descending order, 3, 2, 1, 0, right? And it's x plus 1. So if I'm going to set this up synthetically, I'd put a minus 1 out here. And this would be 1, negative 2, negative 1, and 2. Right? 1, negative 2, negative 1, and positive 2. Now, for us to find the rest of the zeros, this has to be 0. Okay? They kind of softballed it that way. They're kind of spoon feeding you, where this will wind up being 0. Okay? Let's make sure. Bring down the 1, negative 1, negative 3, positive 3, 2, negative 1. Oh, 2. Okay? And it does wind up working out. And I want you to work that on your own. Make sure you get the same thing, but it's that same pattern, right? We're doing that same pattern we've done for probably about 6 or 7 examples now. It's kind of cool. So what if we found that this is what matters now? This is what matters. What if we actually found? And I'm going to kind of go deeper into this. What we found is when we divide this third degree polynomial by x plus 1, we wind up with this second degree polynomial. So what we've actually found, now I'm going to kind of write this on the side, x cubed minus 2x minus x plus 2, it's hard to say for some reason, divided by x plus 1, this is equal to x squared minus 3x plus 2, right? So what's important to us, though, is that because there's a 0 remainder, we know that these two are factors of this quotient, okay? These two are factors of the quotient. So we can rewrite this now. I'm going to go down here and I'm going to rewrite it. F of x, this big polynomial, is actually x plus 1 times x squared minus 3x plus 2. And again, this is like saying when we said 27 divided by 9 equals 3. Well, then therefore we know 27 equals 3 times 9. It's the same thing, okay? It's the same thing, just with big polynomials instead of numbers. Okay, it's the same thing, but just with polynomials instead of numbers. Okay, and look, we know this. Look, if I gave you this function, and if I said x plus 1 is a factor, you tell me negative 1 was the 0, right? And we know it's a 0 because it gave me a remainder of 0. It's all coming together now, okay? But remember, and we talked about this in the last lecture, if it's a third degree, we know there's 3 zeros, right? We know one of them, but we need to find the other 2 here, okay? We need to find the other 2. And look, this is a nice quadratic. What's nice about quadratics is we know how to solve them. We've got the quadratic equation we can always rely on if we need to. But I'll tell you, in this section, in 3.3, you'll be able to factor this quadratic, okay? You'll be able to factor it. So let's factor this quadratic. So this -1, -2. We did it. We factored that quadratic, and it's going to tell us the last two zeros, right? Look, I'm going to be lazy. I'm going to stop right here. I know from this first polynomial, the 0 was -1. The second polynomial, the 0's got to be a +1. And the last polynomial tells me the 0 is a +2. That's my 3 zeros. Use results to find all the zeros. We did. Factored the x plus 1 out. Left me with the second degree polynomial, right? We knew that because it was a third degree. You factor out a first degree, it's left with a second degree. We factored that second degree and it gave us the last two zeros. Whew. Okay. I know. Whew. I hate that they put this at the very end. Like, I feel like our brains are starting to get drained here kind of towards the end. And you might need to like come back and watch this again when your brain's just not as worn out. Okay. And that's okay. There's nothing wrong. That's why I'm glad these are being recorded. Okay, let's do another one. And look, this is written a little differently because I probably don't have time for one more question. Yeah. Let's do 46. Remember I told you that your book uses the word 0, root, or solution. They Dr. Blitzer kind of uses those interchangeably. Well, in number 46, he winds up doing that. And I want to show you why he uses the different terminology. Number 46 states, solve the equation. Now, it's written as an equation, not as a function. 3x cubed plus 7x squared minus 22x minus 8 equals 0. And then given -1/3 is a root. So for us, this means it's a 0. Okay? Given -1/3 is a root. But I need your brain to go, oh, that means it's a 0. We're going to solve it the same way we've been doing it so far. Okay? Given -1/3 is a 0. Now, I chose this one too because it's a fraction. And that way we can at least see one with fractions. Look, we're going to do this the same exact way. I got to be careful on how we set it up. If I want to look, there's 3 degrees here. So I know there's going to be 3 solutions, 3 roots. We know one of them already is -1/3. They told us that, right? And we're going to assume they're not lying and they didn't make a mistake. So -1/3 is going to be one of the roots. I need to find the other 2. And the way to do that is by dividing the -1/3 out. So we're going to start the same way. Look, -1/3 is the root. So therefore, that's what actually goes there. It is the 0. It's not like it's in a factored form or anything like that. It is the 0. So it goes right there. Then I'm going to write this descendingly. 3, 7, -22, -8. And then I might have to crack my calculator if I'm not comfortable with fractions. Bring the 3 down. 3 times 1/3, that's just 1. That's -1. Add this, we get 6. 6 times 1/3 is 2. It's going to be -2. Add that, we get a -24. Times 1/3, well, 1/3 of 24 is 8. It's positive because it's 2 negatives. So we wind up with 0. Look, if we didn't wind up with 0, we did something wrong here because they told us -1/3 was a 0. Okay? They told us. Maybe they lied. I don't know. But I don't think they lied. Okay. So let's see what we have here. This isn't really an A-B question. It's just, hey, solve the rest of it. What we have is, look, if negative 1/3 is a root, x plus 1/3 is a factor, right? X plus 1/3 is a factor. So I'm factoring this third degree down. And then we know the other factor is right here, 3x squared plus 6x minus 24. This quotient here is what's left over. Okay. And then look, I'm running out of time. Let me kind of zoom through this last part. We just have to solve this now. We set that equal to 0. Now, look, all of these are divisible by 3, so I'm going to divide everything by 3. If you didn't notice that, you'll get to the same answer. It's just a little easier if they're all divisible by a number. So we get x squared plus 2x minus 8 equals 0. And then I factor it. X plus 4, x minus 2. And that's my last two factors. That's my last two zeros, negative 4 and positive 2. So we wind up with the zeros being negative 1/3, negative 4, and positive 2. Okay, negative 1/3, negative 4, positive 2. Now look, we're going to talk a lot more about this in the next lecture. 3.4 is really dedicated to this, okay? It's dedicated to finding all the zeros. But I want you to do those last few because they're good introductions to the 3.4 section. So for homework, this will probably not be as much homework as we're used to, actually. Yeah, 17 starts with synthetic. 17 through 45 odd, that's it. 17 through 45 odd. So 3.3, the homework, which is on page 374. 17 through 45 odd. 17 through 45 odd. And then I will, then we'll be going on to 3.4 the next lecture. So the test will be a week from today. I believe if you check your homework, that's correct. Okay, I'm going to stop the recording.